Well, it's great to be here at the Big Comms event here in Austin, and I have to say, like many of you, I'm sure you enjoyed barbecue just as I did last night. So the question is why is data so important to us? And when you stop and you think about it just for a second, and you think about what we do in our daily lives and the things that we do that are associated with technology, almost everything generates data. Just from simple texting to social media to watching a video or uploading a video. And furthermore, data has the real power to change our world. It allows us all sorts of new ways to connect, to learn, as well as discover. And the uses of data has all sorts of possibilities to really enhance the way we live our lives. Everything from at home to at work to how we travel, to even how we view live sporting or concerts. Furthermore, it will truly fuel the next wave of innovation across many different applications in the both consumer space as well as businesses alike. For example, Intel partnered with Nokia, China Unicom, and Tencent to deliver an amazing experience for concertgoers in Shanghai Benz Arena. And in this experience, if a user opted in, they were treated to viewing the concert from multiple different video angles right on their mobile phone. This was made possible through the use of mobile edge computing on top of general purpose servers very close to the user, cutting down latencies as well as reducing the cost of backhaul. Now you can imagine how this could be applied to many different sporting venues around the globe as well as in the United States. And I, for one, like many probably UT Austin fans here in this room, are excited about this technology being located in my home stadium, which is Sun Devil Stadium. So data does drive transformation. And when you think about all sorts of different use cases, ranging from AI to VR to smart factory, these use cases, both far and wide, will truly stretch and pull our networks in so many different directions. And because of this, and the amount of traffic that's expected to flow across our network in years to come, the network must transform. It must transform to a more open, virtualized version of what it is today, more flexible, more automated. And with this enhanced infrastructure, we can truly deliver the promise of 5G and bring out all the underlying characteristics that that standard has to offer. Things like lower latencies, better bandwidth, as well as the use of machine-to-machine communications. Now, we have been on this journey that is network transformation for quite some time. And you could argue today we're probably somewhere in the middle of this journey. And going back to the early parts of this decade when we began this journey, we worked hard as an industry to move the market from a series of fixed function or purpose-built appliances to virtualized servers. And once we had these virtualized servers, we added virtualization on top to deliver the right flexibility. Now, we have learned a thing or two in this transformation, and new architectures and methodologies have arisen. Some of these architecture and methodologies do get us closer, much closer to our ultimate goal of this more flexible, automated, and more secure and service-assured network. Things like Cloud Ready that do have a lot of hype around it today certainly have their place in today's network transformation. But in certain cases, they may not be the right choice for all deployment scenarios. And when you think about cloud service providers, you probably immediately think about how they have really mastered getting the most out of their cloud infrastructure, driving all sorts of efficiencies as well as speeding time to deployment of new services. So comm service providers can certainly apply some lessons learned there to both their technical as well as business challenges. But for comm service providers to really adopt these technologies far and wide across their network, both technical, operational, as well as even organizational challenges need to be overcome to deal with the operator's SLAs and KPIs. So because of this, Intel is partnering with the open source community, with partnering with communities such as the cloud native community and Kubernetes to enable early adopters to deploy virtual network functions that are very data plane intensive in containerized environments. And because of this, we do expect in the near future more cloud-friendly / virtualized deployments, but over the long haul, we do see a migration towards more cloud-ready or even cloud-native type solutions. Now, when you think about network transformation, you probably first think about it how it's impacted multiple industries. It's really impacted both fixed and mobile networks. It started really in central core networks, and then since that time, it's being talked about in regional and local aggregation points, down to the access network, as well as on customers' prem. And of course, while all this is happening, consumers and businesses alike continue to demand amazing experiences. And this is happening while we're planning towards 5G, and of course, comm service providers continue to have both tight operational as well as capital budgets. And because of this diverse set of use cases, as well as the traffic flowing across our networks, I believe the network needs to transform to a more distributed network with pools of compute and storage spread throughout the network. You can really think about this as having many data centers at different points of presence to deliver the right virtual network functions, as well as run the right services. And when you think about today's transformation and where we're at, you would probably say, yes, the network has started to transform, but it has primarily focused on central core networks, things like EPCs, IMS, et cetera. But with the modernization of fixed networks and plans for 5G and people anticipating even all sorts of use cases running across LTE in the later stages of that technology, the attention of the industry has now shifted towards the edge of the network and shifted towards a concept called next generation CO. And this next generation CO, it needs to be capable of running both fixed and mobile traffic. It needs to be able to support roughly 35,000 subscribers as compared to a typical CO of today of about 5,000. This CO is located between the access network and the transport network. And you can really think about this as a local edge data center, which is a much smaller power and area footprint as compared to traditional IT data centers or even hyperscale data centers. Furthermore, this location needs to be able to run a wide variety of network functions. Everything from a broadband network gateway to the user plane of a 5G network to a virtual converged cable access platform and even virtual RAN. But in addition to this, we can't just stop at VNFs. Comm service providers are viewing this now as a strategic location within their network to deliver services, IoT, 5G, entertainment, and so much more. And when you think about those type of experiences, what immediately pops in my head is I think about immersive media, or even just video for that matter. And I think about how that use case requires both high bandwidth and low latency, and how that use case is ripe to be able to be run from the edge of the network. But then I think about today's COs, and I would argue they don't have the necessary storage or the compute to keep pace with that use case, nor are they set up for success with the right speed and nimbleness to really keep pace in the 5G era. So with that, I'd love you to hear what some of Intel partners thinks. So let's watch a short video.
With the advance of 5G and advanced machine communication use cases, we are seeing much more ultra-low latency requirements coming from the cloud-based networks, as well as high bandwidth requirements. And this is the inception of Edge Cloud. To deploy data centers at the edge of the network, Nokia has designed the Airframe Open Edge data center solution. We are not pushing all the applications to the edge of the network though, so we keep centralized the ones which we can for efficiency and scale, and distribute the ones that we must. Through our partnership with Intel, we have been optimizing our data centers for optimal footprint, power consumption, bandwidth, and latency. Over time, we believe that there will be as much compute at the edge of the network as there are in the central data centers.
Telefónica has begun virtualizing the national and regional data centers, where we are hosting most of our core functions. And we are progressing in extending this virtualization to the edge. We have been working closely with the commercial and technical areas of Intel in the definition of network virtualization for a few years. The Xeon scalable processors and NICs are the great asset of Intel, with which we work, and on top of which we are building the virtualization of the network, since they adapt very well to the control layers and network platforms. The ultimate goal is to provide flexibility to the network so that we can deliver functionality and capacity where and when it is needed in a dynamic way, almost in real time.
When you put together innovations on the chipset side along with the requirements needed from the telco side, a lot of things can happen. The next generation of innovations from an applications and network services perspective from all kinds of developers will be enabled. We've been working with Intel on Xeon and the next generation of it because when you get closer to the edge of the network, the ability to scale and also be power efficient is super important in that case.
So we are collaborating with the overall industry to truly bring edge transformation into the fold. We are working with many open source communities in developing different NFV or cloud-ready based architectures so you can seamlessly scale both VNFs as well as services. Now, we just heard from 3 of our partners talking about edge transformation and how excited they are about it. But in addition to this, we are seeing a lot of operator interest really around the globe, looking at all sorts of deployment types, from dense urban environments to rural settings to even suburban settings. Now, Intel is doing our part as well. We are partnering with the ecosystem to ensure that you can run virtual network functions at the right performance you need for the edge of the network. For example, we've shown how you can run on a server a BNG workload between 100 to 400 gigabits of throughput, depending on what you need at the time. And furthermore, since this architecture is highly flexible, you could also run services. Now let's turn our attention to the RAN. And when you think about 5G, it's very unlike other standards. It provides comm service providers the ability to deliver vertical-specific market applications. Furthermore, it allows you to deliver the right amount of resources for that application. Really, not too much, not too little, and kind of like the Goldilocks principle. And when you think about this, you think about virtual RAN. And of course, virtual RAN is the ability to run baseband functions on a general purpose server. And this server is located separately from a remote radio head. And then when you combine this capability with something called mobile edge computing, it really becomes an app developer's paradise, because the RAN is very close to users. So these app developers can take advantage of the real-time radio information, as well as delivering fine-grained analytics to tune and innovate different services for years to come. For example, we partnered with the ecosystem, leveraging our FLEXRAN reference architecture of virtual RAN in combination with mobile edge computing just earlier this year at the Korean Olympics. And at these Olympics, if you attended the ice arena, you had the opportunity to enjoy an immersive experience, virtually walking on to that ice arena. Now, as we've discussed, the network of the future, it needs to have the ability to be personalized as well as customized. It needs to be flexible and open and agile. And one of the key technologies that pulls all this together is something called network slicing. And essentially what network slicing does is it provides comm service providers the ability to slice the network for a specific vertical market application, but run this slice on top of their homogeneous network. So this does 2 things. It delivers the right QoE for that application, as well as helps with TCO. And you can imagine how this could be important in the era we're going into, where we're expecting all sorts of diverse use cases, ranging from IoT, which sometimes has very low latency characteristics, as well as low bandwidth, to things like video, which of course is high bandwidth as well as low latency. Now, we are such believers in this concept that we are innovating in our Oregon 5G lab by type of service, by type of air interface, as well as we're working on dynamic slicing. And all of this will be given back to ONAP as part of our open source contributions, because we believe technology like this are critical to fuel network transformation and truly power the 5G era. Now, one other innovation that I would like to talk about is something called the universal CPE. And the universal CPE has the promise to enable greater efficiency in WAN connectivity, as well as enable customers to run all sorts of enterprise services from the cloud. And when I talk to our partners, the comm service providers, about why they are so excited, and really why their customers are so excited about this technology, they bring up a couple things. First, and probably foremost, they bring up the ability of the universal CPE to run something called a software-defined WAN. And what that is, it's a software-defined interface on a virtualized server that allows you to manage your WAN connectivity, but in a much simpler fashion, as well as at lower cost points, or better overall TCO. But in addition to this, with its connection to the cloud, the comm service providers now have the ability to deliver a rich set of enterprise services. So things like firewall, intrusion prevention, and application delivery controllers. So this can greatly simplify how enterprises really automate and provision all these workloads, as well as possibly even reduce the number of fixed function appliances in their network. And because of this, analysts are projecting this market to grow quite rapidly. For example, IDC is projecting this market to grow to $3 billion by 2021 at quite a rapid pace. Now, Intel is certainly doing its part here, innovating and delivering all sorts of different hardware, reference solutions, as well as different silicon solutions. And in fact, I'm very happy to announce today that we are introducing the Intel Select Solutions for Universal CPE. These select solutions are reference architectures that are designed to deliver the right performance and right reliability for virtual network functions that I mentioned earlier: ADC, software-defined WAN, firewall, and so on and so forth. They are set up in a way to be able to speed OEMs' time to market, since they're built on proven Intel recipes. And since they're built on these proven Intel recipes, comm service providers can have the confidence that they select an ecosystem partner where there's based on Intel Select Solutions, they can run a wide variety of virtual network functions. Now, in addition to this, I'm happy to also announce that we have 5 partners in the coming months that will also be introducing solutions based on Intel Select Solutions. They are Advantech, Lanner, Premier, Silicom, as well as Supermicro. Now, through this highly distributed network, comm service providers need to make choices on their platforms at each network location. They will need to choose based on many different characteristics, including compute, bandwidth, latency, as well as storage. Now, the good thing is Intel has introduced in the last 12 months 3 tremendous products that deliver top-to-bottom scale: the Xeon Scalable Processor family for outstanding performance, the Xeon D for performance density, which is also, that's the foundation of those Intel Select Solutions, in addition to the Atom C3000 for power and price-constrained environments. Now, in addition to this roadmap has architectural consistencies, so you can seamlessly scale those VNFs really dynamically across your network. Now, but before I move off this subject, Intel also does support all sorts of other technologies, such as FPGAs, Ethernet, as well as Quick Assist technology. So I have one more announcement to make, is that Intel is introducing our latest and greatest Intel Quick Assist adapter card, the 8970, which doubles the performance for crypto acceleration up to 100 gigabits per second. In addition to this, we see a lot of our OEM partners adopting this technology alongside Xeon Scalable Processor family. It's these sort of innovations that will truly fuel network transformation in years to come. Now, Intel does continue to invest with the broad ecosystem, working with our partners, the ISVs, the OEMs, the TEMs, and the comms service providers. We're investing in all sorts of different open source efforts, ranging from FDIO to DPDK to Open Daylight to OPNFV, and so much more. And many of our innovations, they do center around the CPU and the NIC. But what we try to do is we try to deliver these innovations in a way where we can develop standardized approaches to use the underlying architecture offered by Intel as well as others. And furthermore, we do contribute at higher levels in the stack, things like ONAP, which we know are critically important to service orchestration. And then finally, we have a program called Intel Network Builders that brings together the broad community in the aim of network transformation. And I'm quite proud that we have over 260 members today that are delivering over 80 unique solutions to support network transformation. So with that, I'd like to thank the audience here. I'm truly excited to be partnering with many of this room to bring network transformation to the market. Thank you very much.
Great, thank you very much, Dan, and thank you for bringing your uCPE news to BCE. So I just want to ask you a quick question. You talked there about the development at the edge of the network, edge data centers basically being built in central offices. That's the plan. But we've been hearing about this for a couple of years, and people have been talking about distributed cloud and fog, et cetera. What is the reality in the market at the moment? What are you hearing back from the market in terms of where network operators or anybody else building out edge compute capabilities, where they are in terms of that process?
Great question. So we did hear in the video from 3 of our partners and their excitement around edge transformation. And as I mentioned, I do see a lot of excitement around the industry, really ranging across the globe. And I think one of the key use cases that we're seeing the most traction on this year is the universal CPE, as well as the use case of software-defined WAN. And I think the other use case where we are seeing a lot of momentum, particularly building out virtual BNGs, is around modernizing the fixed and the mobile networks at the edge and the concept of next generation COs.
But still a lot of work to do in terms of developing the COs so that they are essentially cloud capable?
Yes, there is work to be done in the open source communities, as well as developing the right reference architectures to give comm service providers the tools they need to roll out these next generation COs with the right cloud infrastructure and have the confidence that they can really run those services and those VNFs at that local edge data center.
Okay, excellent. Dan, thank you very much again. Thanks for joining us today. Let's have another round for Dan, please. Thank you.